So good to see you here, all of you online and here in the room. So I'm obviously Hans Lindetorp, and I would like to present my research so far. So we're sort of midway. It's a little bit more than that, I guess. But anyway, 50% today. So this is what I will do. I will start with a demo, trying to kind of expose you and involve you into the field I am researching in, so we know what we're talking about. And then I will talk about why I'm interested in doing this research at all. And then focusing more on what I am actually doing and what kind of knowledge I'm trying to create. And then how I do it. And then hopefully we have some results so I can tell you what I've seen so far. And finally, I will talk a little bit about the future, the following years, what I want to focus on during those years. But now time for the demo. So please, fingers crossed and everything. Hope that it works. And I can also mention that you saw a QR code in the beginning of the presentation. It will come back at the end. And that is the QR code to everything you see today. So it's the slides, the demos. You can try it yourself tonight before you go to bed. And you can read about the text that Norbert, at least Norbert, has read. So here we go. The demo is online. And this will involve some music and some interactions. So I will stand here and move my hands, but you should look on the screen. So you can see my hands there, and you will see a machine learning component analyzing my hand, trying to find my joints. And the data from those joints are sent to my system, mapped to audio settings and musical composition. So what you hear is controlled by my hands. So it's important to kind of see what I do and listen to what you hear. And you can especially note how I raise my right hand, how I raise my left hand if I do that, how many fingers I raise, and if I touch my pointing fingers. That's the interaction I'm able to use for this demo. Okay, so hope this works now. We press music on. The volume is down. Yes, thank you. We had some sound, didn't we? Det trixiga här är ju att jag måste köra zoom ut där för att de ska, men zoom skickar väl tillbaka det till den utgången tror jag. För vi hörde ju. Ja, det gör ni ju inte här. För då. Jag är så glad att jag det. Det är rätt. Ja. Vi ska se, vi laddar om. Så. Can they hear online as well? So this is me breathing. And what you will hear is not my composition. It's a tribute to my youth and to Charlie Parker and to electronic music. So it's just my right hand. It actually worked, which made me really, really happy. So what I will do now is to quickly just describe what you heard and what happened and how it was controlled, so you understand the sort of basic technical side of it. So I think I close the window so don't have any accidents. And back here, back to Logic is actually the way to go. So it all started here in Logic. I produced some tracks. So if we listen here, you can recognize everything that you heard. When that is done, then everything needs to be exported into smaller pieces so it can be built together with the system. So everything is exported into separate audio files like this. So for example, we have the drums, sort of a breath, not drums. Let's go for this one. The cymbals. Some keys and bass. Some lead vocals. And strings and horns and stuff. And the whole thing, what I will talk about now is how is this put together and how is it mapped to interaction variables. That is kind of what my work is about. So when the music changes in intensity, that is controlled with a variable. The variable is read from my pointing finger, the height from the bottom to the top, and is translated into a mixer. And there is a system here dealing with 5 different versions of the bass and keys in this case. And how I move the finger will control the volume of these 5 different versions. So you will hear one at a time, and then it's switching very quick with a very quick crossfade when I change from one region to another one. And all the different parts in the music is controlled in this kind of way to move through the different intensity versions of the music. The breathing in the beginning is a bit more complicated. So the system counts the number of fingers, which is actually just measuring the distance from my top to the bottom of the hand, counting how many fingers are actually pointing upwards on my left hand. And then that will cause a variable from 1 to 5 or 0. And those values, you can't see my pointer now, but you can see map in here at the top. It's mapped. So number 1 is mapped to number 44 on the first line, and number 2 fingers, is mapped to number 41. And if you're into music production and media and stuff, you might recognize those numbers as very useful bass notes. So it's actually note numbers that are all the way to the right, converted to frequency values. So by raising my fingers, I am mapping 5 different variables to different frequency values. And those are mapped to bandpass filters. And those are the ones you can see at the bottom here, visually taken from Logic. So you can see what it would look like if we would have a graphical interface. So it's taking a bandpass filter, raising the Q value very high. So from my breathing, we pick out the most kind of central pitches around that frequency that is set for that filter. And if we take several filters and put different frequencies of these, we get a chord, and that was exactly what you heard. And because the mappings on the first 5 lines map to different values, I need to just go there. This will be the matrix of the different values matching the different fingers, making up the chords when I change the fingers. So that's how that works. The whole topic we're talking about is music production for interactive media. And we try to kind of use a shorter word for that sometimes, like interactive media. But the field is not like totally determined about what to call it. So some say adaptive music, some say modular music, some say dynamic music, and some even say, not my supervisor, but I might do, flexible music. So that might be an interesting area to actually talk about and look for what people actually use the different terms for. But I will talk a little bit about fixed and flexibles as 2 different things when it comes to music. And I argue that music is inherently flexible or interactive by nature in how we as humans relate to music. So we've all the time, I guess, been dancing, playing, singing, storytelling, worshiping, and whatever we have been doing with music as humans. And music has then played a very interactive part together with whatever else we do as humans. Then at some point, we invented the music notation, and that made the music a bit more fixed in its form. So then we could have a composer composing a specific sort of set of notes that should be performed in a specified order. And then we have a fixed composition that got spread all over the world through the printing press. And then we have the recording facilities that when we could record a performance of this fixed music, then it was even more fixed, because then the performance itself was the same every time we listened to it. And we got the CD and we had the vinyl, and now we have streaming services, but the format is sort of, say, fixed still. So when you listen to a track on Spotify, you will hear it exactly the same as you heard it last time. You would be a bit surprised if you get a double chorus when you listen to it tomorrow, if you didn't hear it yesterday, for example. But in the meantime, DJs and others have been kind of playing with the technology and trying to find flexible approaches to this a bit static format, which is a recording. So DJs have been exploring that for quite a while. And I would argue that we are now in a perfect time when the flexible or the interactive format of music can really explode, because the computers are now really powerful. So we can do all sorts of clever things with them and use music that is pre-composed and produced, but not necessarily fixed in its form and shape. And that has been explored, especially in computer games, as we know it for now. But I argue that the potential here is fantastic. So let's look at what we could do. So this image in the middle represents this kind of flexible, or whatever we call it, music. And you just saw me sending signals to the system through my hands and my gestures. But we could potentially take data from any kind of equipment, really, like game consoles, or even our smartphones are packed with different sensors. We can measure the accelerations, it can measure how we move it, how we tilt it, what temperature, the sound volume, whatever. We can take ordinary digital instruments and send signals to a system, or really experimental electric equipment and connect different sensors to the system, or use like DJ stuff, or take data, statistical data or real-time data from anywhere in the world and feed the system with this data. And then we can output it for different purposes. So as I said, computer games is maybe the best explored field for this type of music, but we can use the same approach when we build instruments. We can do, like this is an installation here in Stockholm called Ljudskogen, or Sound Forest, where we can build really interesting multisensory, huge interactive instruments that is interacting with audio in one way or another. Or like the theater, we can have a produced sound and music that adapts to the acting on the stage. And then we need a similar system that matches the music with whatever happens on stage. The DJ scene, of course, but then also for research purposes. And we call this field sonification, when we take data and we apply it to sound. So we use the data to control the sound, and then we can listen to the data, and suddenly we can hear the data in a way that we couldn't see. And that makes us actually learn things and create new knowledge by listening to the data rather than just looking at graphs. So it's a really interesting field as well. It's a lot of ongoing work, both on the industry stage with FMOD, WWise, and Elias as being popular platforms for implementing music into games. And of course, it's on the way now with virtual reality and stuff. Then also a lot of different studies and frameworks and technologies and prototypes trying to support the creative process of creating and implementing sound and music into interactive environments. So for example, I can mention Soundworks, especially because we have Norbert here. It's his project. But we have a lot of different interesting projects going on at the moment. And the ones you see to the right is actually more traditional tools used for interactivity and sound, but they're now being ported to the web. And I will soon tell you why, but more and more towards the web now. But even those older programs, they have very interesting projects going on, porting them to the web. So it can all be used online in the happy, clappy web world. All right, to the question why I'm interested in this at all. So it started more than 20 years ago when we founded the bachelor education in music production here at KMH. And we always have a lot of really talented students. They're great at music. They play, they sing, they compose, arrange, record, and produce music. And they want to reach the world with their music. And they sort of manage, because it's a streamlined process to create ordinary music and publish it and stream it through web services like Spotify. But when it comes to create music for interactive environments, they run into problems because they are not good at programming at all. Or what do you say, Simon? So they don't have any experience at all. They are not programmers. They are musicians and music creators, really. So what happens when we expose them to programming to be able to do this, they often get sick and tired, and they lower their artistic ambitions in their project. And this has been kind of something I really want to challenge in some way. So I will get back to how I try to do that. But first, I want to say something about humans and technology from my perspective. I think we have collaborated with technology all the time. From we made the first flute and we played on it, we were kind of playing with technology, making music. Current technology, the digital technology, is super interesting in many different ways. For example, we can have machine learning algorithms composing and generating music, or we can have technology pretending they are an instrument, a virtual instrument, so we can make electronic music. That is great and very interesting. But my research is focused more towards human expressions and having technologies supporting human expressions by being as transparent as possible, supporting whatever quirkiness we do when we play and sing and do music, and support that in this field of interactive media. I have another value which drives me towards the web, and that is that I like inclusive technology that is available for everyone, everywhere, all the time, no matter what, if it's like super good. So I like universal design and open standards and all those expressions for developing technology rather than having something limited to just my own practice. And before I tell about my own study, I will tell you about 4 different technologies that have had a great impact on me, of course, but I would say to a very big extent. And the first one is Midi. It happened during the 80s when they connected 2 keyboards to each other, playing on one and the other one sound along with the first one. That was the kind of intention with Midi, to be able to connect musical instruments. But Midi has become a foundation for a whole new way of producing music, I would argue. So all the modern softwares we are making music with heavily built upon Midi in one way or another. And it's still actually running, even if it's now 40 years old. Another software that I love or hate, I don't know about you, but it's something with spreadsheets and Excel that is just amazing. And the most amazing thing, I think, is that you can, of course, put a lot of numbers in different boxes. But the cool thing is that you can also put a snippet of logic expression in a cell. And that expression will take the content of other cells and do something new with it. So the logic you express in that cell will take the sum or the multiplication or the subtraction or whatever from different cells, and you get a new result. And then Excel will use, if you want to, a diagram to show the result of your calculations. And that became a super powerful tool for finance people to actually understand what they were doing, because they could create the piece of software that they would need for their purposes. And I argue that that is a very good approach to developing technology, to allow the user to describe snippets of logical expressions to then together form an application or a system that does something. So that has had a great impact on me. And then HTML. Don't know if you kind of live with HTML, but you use it every day, because HTML drives the web. Everything you see in a web page, no matter if it's on your smartphone or your computer, it's always written in HTML. So a web page is described, as you can see here, with titles, body, headers and paragraphs, images and stuff. So this is how web pages are described. And I think the combination of this simplicity and the clear style of the language, together with the possibility for a computer to read it, so both humans and computer could read and understand what we were doing, made that kind of boom that made it possible for the revolution on the internet to happen. And that has had a great impact on my work as well. And finally, Web Audio API. So when we got the web, it was just characters and images. We could read and we could see images after a little while. It took a long time before we could hear any audio or see any video. And it took even more time before we could have audio that interacted with whatever you were doing in the web page. But now we have Web Audio API, which means that if you take your smartphone or your tablet or a computer, you actually have the engine to have a really powerful audio software right in your phone just by going to a URL that uses Web Audio API. So it's a super interesting, I would say, engine built into every browser nowadays. And there's a conference, super interesting conference that I've been to several times called Web Audio Conference, where most of the kind of connected scientific work to Web Audio API is presented. Okie dokie. So what am I doing? Back to the problem. We have the students, we have the problem with the coding. Then I try to make a road kind of through that or into that or whatever, but for my students to take the creative, artistic ideas and vision and to create it and make it happen and make it distributable to the world in a kind of, maybe not as easy, but at least possible way as they produce and distribute ordinary music. The project I am working on is called Web Audio XML, and that is a descriptive XML-based language to describe the audio configuration in an application. So if you imagine a web page, we have HTML to describe the images and the text you see in the web page. I use XML to describe the oscillators, the filters, the gain nodes, the tracks, the regions, the arrangements, all the kind of sound and music related objects in an application. And as I'm designing and developing Web Audio XML, of course, I get tools like prototype tools that we can use for our practice here at KMH and at other places. We also, when we do it, we find terminology and syntax that is useful because I try it out on student groups and we discuss the usefulness of the different terminologies. We also find strategies by trying out ideas and evaluating them. And that is also contributing to the scientific output. All right, so how do I do this? Well, I would say it's an iterative process where I use research through design for the art. So these are like fancy words that we use here when we do research. So I research through the design process. So by designing, I actually create knowledge. And I do it for the art. So we have different ways of dealing with artistic research. And I don't necessarily create new forms of art. And I don't necessarily research through the art, but I research mainly for the art. And I research through the design process. The iterative process often works like this. I have a student group. They have ideas. They get a task and they have ideas of how they will create music for an interactive situation. We discuss the challenges, and maybe a few of them are new to the system and can't be done yet. But then we discuss how that would possibly be kind of described in an XML language. I prototype, implement it, and they test it, and we evaluate it. And then I describe and present articles about the findings through this process. And then we have a new version of Web Audio XML for the next season of students. And then the process goes on and on, over and over again. Another method that I'm using is Annotated Portfolio, or rather a method I'm using to kind of capture what's going on in this iterative process is Annotated Portfolio. So I take notes almost every day, writing about ideas that I see, roads I've chosen, roads I've not chosen, and things I see away. I also use a lot of comments in my code so I can see what happened here, why did I do that, and so forth. So that's one way to kind of lift the implicit knowledge hidden in the designer so it can be kind of seen and discussed by the broader community. Another method that I use is to run focus groups. So typically after a class, With students, we sit down and we discuss. I might have questions to lead them. They might have free thoughts and reflections upon the work. And sometimes they also write about their work, feeding back to me. And then I analyze what I get from the focus group and the reflections and summarize it in articles. I also use some quantitative methods like online forms, trying to better understand where my students are coming from, how they perceive different things, and stuff like that. I also tried to build a measuring tool in the system itself. So when my students build things, it's auto measured in terms of complexity, and so like how many oscillators, how many mappings of frequencies to any interaction variables and stuff like that can be measured in the system. So I've run a lot of studies and projects so far and written some articles about it. And first, a few that I've written together with Emma Fried, for example, about the sound forest and how to compose for a multisensory instrument like that. I've written with Kjetil and colleagues here about student involvement in research and how we do it here at KMH and KTH. And also two articles about creating digital instrument with and for children. And finally, an article presented, written by me and Kjetil last summer. So all these are peer-reviewed and published. Today I will focus on 4 selected publications that I included into this seminar. I've written them with Kjetil, my main supervisor. And the first one was presented at Sound and Music Computing Conference 2020. That was the first time I presented Web Audio XML. I collected a few experts discussing the syntax and the concept, overall concept for the system, and describe the process and the output from the discussions. And next year, last summer, at the same conference, we took a new step with the parameter mapping process and the variables I've showed you right after the demo in the beginning. That was also similarly discussed with a few experts in the field. I also included a paper from the International Conference on Auditory Display. It's a very complicated name, but it deals with mapping data to audio, so sonification and other ways of dealing with data and audio. And I created an online tool for students without any programming, nor music, nor sonification, nor music production experience. And their task was to create a sonification from some interesting statistical data. And the result was actually quite astonishing. They managed to do really interesting things. So that was cool. And the last paper is submitted, not yet accepted, to Journal of Audio Engineering Society this year, where we collect experience from various projects with students and Web Audio XML for using Web Audio as a learning platform. So what have we learned so far? Well, in early projects, we actually realized that Web Audio API is very robust. We had an exhibition going on at the Nobel Prize Museum for 3 months, and the students here, they created 1,000 files that was randomly picked over 3 months, and it just kept on running in 16 multi-channel speaker setup. So we were quite impressed by Web Audio API and the performance itself. We also did a study with smartphones and Klangkupolen, which is a 29.4 channel setup here at KMH, to try how the technology would work to make experimental, interactive, multi-user, multi-channel, multi-sensory, multi instruments. And that was also very, very inspiring to see how well that worked, even if we also learned that the students really did not like programming in JavaScript at the time. So then we presented the XML language and got a very positive feedback, mainly that it was easy to understand and that the experts could see a great potential for the language. We then used it through a lot of different student projects, and we found really useful strategies for mapping variables to audio parameters, like the ones you saw in the demo in the beginning. Recently, we've also built some online tools for doing those gesture things and coding web audio XML straight into the browser. And this is a really important thing that we learned, that the online tools heavily reduce the time for getting started with learning anything. So we just get rid of all the download, installation, incompatibility and hardware and stuff like that. And we just open a web browser on the link and it works. So that's been important and very good. We also learned a lot about the really important pedagogical insights for interactive music production. So every year, I would argue that we've taken a few steps in a very good direction. But I would say students that are sort of a bit scared towards the text-based way of doing things when it comes to computers, they are still a bit scared, because if they write one little character wrongly, then it doesn't work. So text-based language is still a problem for our students sometimes. Some reflections from me on the results. Well, one thing is that I really realized how much technology shaped music. And I argue that is true for any musical instrument or any musical program, that it has an impact on the music being created. Especially true is that when it comes to template files. So for our students to be able to do something, we need to provide them with a starting kind of a boilerplate where they start off their work. And whatever we implement and add to that template, and whatever I show when I present the technology will have a huge impact on what they create, because that kind of sets their sort of limitation about what this system is good for and what you can do. Like if you hear someone play piano and you expect that that is how you play piano. Another really interesting thing is that I come from doing studies to learn to what extent my technology and my ideas have solved a problem. But then when I try to measure that kind of ratio on how well it solved the problem, then the students can't really relate to it because they don't see the problem. They just expect it to work. And I realized that is the same when I log into my bank and I take my smartphone and it just recognizes my face. And I am not impressed, and especially not my wife, all about the machine learning technology behind that process of my phone knowing that it is me. But it's actually quite complicated. So that's been kind of a disappointment first, that they don't realize how super complicated this is and how many hours I spent trying to solve it for them. They just expect it to work. But I guess that's exactly how we humans work. So that means that the feedback and the data output I get from my studies is not so much to kind of say that this is so much better than the old solution, but rather getting really interesting points pointing forward for the next step to take. I also think that the annotated portfolio, which is a debated method amongst researchers, because what is that? I'm writing notes to myself about myself. So it can be a bit, blurry and a bit untrustable and stuff like that. But still, I think over time that when I collect the different kind of roads I've taken and the ones I haven't taken, I am able to contribute with something more generic and useful for other developers and designers in the future, possibly exploring roads that I have not taken. Finally, a few words about quantitative measures and creative work. Honestly, it's quite useless to measure how many oscillators and filters my students have used and then give them a grade saying that was super creative or very artistic or anything like that. So it is useful to measure if the students have learned the basic technical skills, but I would say quite useless when it comes to understand the depth of what they have created. But interesting over time, I think, is because we have 8 years now of research time during the PhD. So I can collect quite a lot of data, both through the online forms and through the system itself. And I just have a feeling that that could potentially actually contribute with some quite interesting data. So what happens next? Well, one thing is that I will combine the two areas of my code, both the area, I didn't really make it explicit in this presentation, the area of describing the musical form, arrangements, tracks, regions, options, stingers, different musical objects, and the audio object, which is more mixer or synthesizer related, like oscillators, bichord filters, envelopes, and stuff like that. But I will merge them into one language. And I think that will be very, very powerful and open up new doors. Another thing is that the technology tend to be very rigid when it comes to especially beat. So as a lot of different technologies works really well when the music is quantized and it's symmetric time signatures and it's all steady. But as we know, humans are not steady. We vary all the time. So to be able to support my deep value about the human expression, I need to take a few steps forward in terms of having the technology itself being more flexible and less rigid. And I think that one of the most important things will be to look into how machine learning can be used as a tool to deal with and sort out all those tedious work that otherwise would have been needed to be done manually to find those, downbeats or whatever. But if we can use machine learning and algorithms to find that combination could be super powerful. And I will manage to run at least one project trying to kind of play with that function as well. And that was my presentation. And if you would like to kind of repeat, because I tried to speak as fast as I could, then you just use that QR code and follow the trace.